So I want to start not with a brain break. I want to start with just a little revision question from last time. I want to see, based on the last lesson, can you, Zakele inherits, I don't think we did this question, Zakele inherits 10,000. Does this look familiar, guys and girls? Actually, I've forgotten if we did this question. Otherwise, I've got another one. Okay, cool. Then let's do this just as a warm-up question for today. Zayn, do we have stuff on statistics? Oh, goodness, we have lots on statistics. So we have so many lessons. So if you go to the Watobe website and you click on classes, grade 11, you'll see that there's a whole collection of lessons on stats. And so I think, yeah, I think we might have even done like 8 last year. We did 8 this year. Oh, so yeah. Okay, cool. So I want you to try and solve this question. Based on the last lesson, what is the first thing we should be doing when we start a question like this? Timeline. I couldn't have said it better myself, Trisha. So we must start with a timeline. And the most basic thing on the timeline is how long does this thing grow for? But I want you to try and fill in the other parts of the timeline now and tell me done when you feel like you're done filling in your timeline. By the time I'm finished with you, you guys are going to be able to do timelines in your sleep. I promise. And these questions will hold no fear for you. Okay, Nompilo has asked a really good question. What does half yearly really mean? Okay, if you imagine we have yearly, we have half yearly, or sometimes they say semi-annually. We have quarterly. We have monthly. We could have weekly. And we could have daily. Now, a year or an annum is just basically what it sounds like. And normally our interest rates are given as per annum. So let's say, for example, 0.084 per year. Now, all I did there was I converted it to decimal form. If I wanted to be half yearly, I would divide it by 2 because that's what half a year is. If I wanted the interest rate to be per quarter, I would divide by 4. If I wanted the interest rate to be monthly, I would divide the yearly rate by 12. If I wanted it to be weekly, I think there are 52 weeks in a year. And if I wanted it to be a daily interest rate, I would divide by 365. Okay, so Nompilo, does that help you understand what the different words mean? I'm sure you will not the only one in the class, and so I'm so thankful for your question. So if we look for the first 4 years, we should have 0.084 per annum. And sometimes I go divide by 1 just to remind myself. And then here, what you have is you have 0.092, but this is compounded monthly. And so I'm going to divide by 12. Now, this is the important bit of the thing, but there's one thing I've left out. What is the important bit that I've left off my timeline? What's the key piece of information? Oh, maybe this should have been divided by 2. You are absolutely right. I was being a bit of a nana. Because the words clearly say half yearly, and half yearly should mean divided by 2 if you look over here. Thanks for that. Now, what is missing from my timeline that I still need to fill in? The amount invested. Yes, so how much money was actually going to grow? So this is the 10,000 Rand that you start with, and it grows at the interest rate above, and it gets to there, and then it grows at a different interest rate up to the end of that. And so your next step, and this is what we covered in the last lesson, so if you weren't with us, you might find it a bit confusing, but what we need to do is we need to see a path whereby the 10,000 can grow. And the first thing is we need the correct formula. And the compound growth formula is what I'm going to use. And if I start with 10,000, what's going to happen, I'm going to use a different color, is I'm first going to grow, I'm going to leave this, I'm going to grow it using this formula, and I'm going to say 1 plus, and I'm going to put the interest rate that is in the green zone. So I get, but now I need to ask myself, how many time periods should be here? So who can tell me what should go in the square block? Now, remember, the time periods need to match the interest rate, and the interest rates are for half years. So what should go up here? And there's a couple of different ways we can do this. There's one trick I didn't tell you in the last lesson, which might help, is to say, well, look, how many years is this? And it looks to me like it's 4 years, but the answer isn't 4, but you can write down 4 if you like. Then you can say times that 4 by the number that you're dividing the interest rate by. And 4 times 2 is actually just going to give you 8. Now, in the last lesson, I was more saying, look, how many half years do you have in 4 years? And you can go, well, there's 2 in the first, there's 2 in the second, 2 in the third, 2 in the fourth. And that will also get you 8. But what I was thinking about is that maybe starting by looking at years and translating into half years by multiplying by that number could make it easier for students. Now, that amount of money is how much I have at the end of the 4th year. But in order to get to the end of the 8th year, I have to grow again. So I'm going to go 1 plus, and all I'm doing now is I'm really treating this first bit over here as a big p-value. It's kind of like it's being that. And now I'm growing it for 4 more years. But the tricky thing is, in the second part, the interest rate is per month. So I need this bit up here to be in months. What should be in the blue square? What should be in the blue square? So really, how many years do I have? I have 4 years, but I don't want it in years. So I times it by the number I'm dividing that by, and that should be, you can see it's 48. Now, the last thing that can mess you up is if your calculator is not working properly. So in order to get this relatively easily done, I would say go 10,000 times open brackets to the power of 8, go equals, and then times this bit equals. And what number are we getting for our final answer? Okay, be careful with your calculator. What are we getting for our final answer? So you should be getting, the final answer should be that. And the way that you can type it into your calculator and make life a bit easier for yourself, otherwise you run out of space and you forget what you've done, is you type 10,000 and then you do this first bit and you hit equals, and then you go times the blue bit here, and then you go equals again, and that will give you your final answer there. Okay. Now, there's one trick that I've left out though, but I'll get to that in a moment. Give me a thumbs up if you're getting to 20,051. Give me a thumbs down if you're not. And be honest, I might be going too fast. So the way I'll judge is by the thumbs up and thumbs down. Okay, now there's one part of this question which is a little bit different to before. Calculate how much interest he has accrued on his inheritance. Now, interest is the difference between what you start with and what you end up with. So can you work out how much interest he has got on his initial inheritance? What do I need to do to find out how much interest? So if you think about what I started with, all I need to do for interest is take what I've got at the end and take away what I started with, which was 10,000. So how much is that minus that? Well, I'm pretty confident it should just be that. So that's how much interest has been earned by leaving the money in the bank. All right. Let us, that seemed like it was okay. So let's do another question like this, except I'm going to take it up a notch a little bit as well. So here is the question, which is very similar to before, except I'm going to add some extra deposits. So let's go through the question together. Oh, that's a good question, Impor. So Impor has asked, isn't interest calculated in percentage? Now, there's a difference between the interest rate and interest. If we say interest rate, it's a percentage thing for units of time. Rate means percentage per unit time, whereas interest by itself with no rate is just the difference between the beginning and the end. Okay, but that's a very good question. Well done on picking up that subtlety. Okay, so let's look at this question here. At the moment, it says Sipho invested 30,000 for 6 years. Okay, so that's the time that we're dealing with. The investment earned interest at 12% per annum, compounded monthly for the first 2 years. Then the interest rate, now notice the word interest rate, not interest, changed to 10.8% compounded semi-annually for the rest of the period. But I'm going to spice it up. I'm going to say there was another deposit. I'm giving you remix questions here. Another deposit of 5,000 Rand. And we shall say after year 1, and another deposit of 2,000 Rand after year 5. So I want to ask the class, I'd love some comments, maybe even audio comments from people. How is this going to change? I need to figure out how much money is left in the account after 6 years. That's my goal. Like, what is the final A value? How are these extra deposits going to make life difficult? What do I need to do to not only figure out what the 30,000 grows to, but also these things over here? Who has some ideas? How can we handle this problem? That not only do we have an amount growing from T0, which is the 30,000, there are extra deposits that have to be coming online. Okay, Emmanuel, I couldn't have said it better. You always start with a timeline. So even though there are extra deposits, I don't stress. And I don't stress because I know that, first of all, I do the things I can do. So I know there's a T0. I know there is a T6 because that's how long everything is going on for. Can you please put the interest rates and the other bits of the timeline on for yourself? And then I'll talk about another deposit part. So you do that. And when you've done your timeline, you just say done in the chat. Ask yourself, what do we need to put on your timeline? Right. So I think that our timeline, our basic timeline should look like this. I have two interest rates. I have the green and the blue one, and hopefully I've transferred the information correctly. Now, the thing that I pointed out earlier is that I know that I'm going to have 30,000 at the beginning. That amount is going to have to grow through the green and the blue. But now these are these interesting things over here. And all I need to do, and this is what's wonderful about maths, it's so beautifully succinct and elegant to, like, when you add this idea up, is that you go, this comes on the scene at the end of year one. So I'm going to put a T1 to show me that visually that's when this amount arrives. And below that, on a separate row, so I don't mix it up, I'm just going to put plus 5,000. Now, what am I going to do? That's how I handle the 5,000. What am I going to do to handle the 2,000? Who would like to tell me? You can put your hand up, or you can put in the chat. What do you think I need to do to handle the 2,000? Oh, it is meant to be divided by 12. Yes, that was me leaving something out. That should be 12, yeah, because it's per month. So Bongakosi, you're right. You add a T5 because that is when this amount arrives on the scene. And on a separate row, you add 2,000. And Trishan, I absolutely agree. Okay, now the good news is you've really made this question so much easier now. But before I go to the next part, give me a thumbs up if you followed what I did there, because I just want to see how many of you I've lost at this point, because that was tricky. Understanding like why these things are not all beneath each other, but rather out of line with each other is the first step that's tricky. Okay, so now here's the next one. We know all of these amounts need to grow using the compound interest formula, but we're going to handle each bit separately. So we're going to handle the 30,000, and we are going to give it, it's got two blocks that it needs to go through. It needs to go through the green block, and maybe I should use colors just to make it clearer. So the green block, it needs to travel through, and it also needs to travel through the blue block. Can you tell me what you get at the end? Now you're going to have to figure out the missing bits. How much does the 30,000 get to once it goes through this journey to get to the other side? So what does the 30,000 get to? Now I'm just using the 30,000 at this stage. What's this going to be? It's going to be 2. It's not going to be 2. It's going to be 4, because it's 4 years times 2. Because it's 4 years to get from T2 to C6, and then you times it by 2 because of the half years. Now, once you put this in your calculators, you should be getting 58,017.51. I want to give a bit of time for everyone to try and get that. And If you do get that, put that in the chat. If you get something different, put that in the chat. Okay, well, let me see if I was using, let me do it myself. So 30,000 times 1 plus 0.12 over 12 to the power of 24 equals times, open bracket, 1 plus 0.108 over 2 to the power of 8. I get 58,017.51. Now, that is not the final amount in the bank account. What we need to do is we've dealt with the 30,000, but we still need to grow the 5,000 and grow the 2,000. Now, in the last lesson, I was putting these all on the same line, and there's nothing wrong with that, okay? But maybe for some of you, you want to do this in steps. So instead of writing them like all in the same line, all I'm going to do is I'm going to do them as 3 separate things underneath each other, just so that you can almost, and then add them together at the end. And that, I think, might make things a bit easier than trying to do it all on the same line. So if you imagine, I still have a 5,000 that needs to grow, and I still have a 2,000 that needs to grow. I'm going to call this like 1, 2, and 3. I want you to figure out what the second deposit ends up being, and I want you to try and figure out what the third deposit ends up being. And I want you to just tell me in the chat what you get for the second and the third deposit. See if you can do it using the timeline that you have in front of you. And then we're going to take a break after that, because I think we've been working hard and our brains need some TLC. Ask yourself, what does the 5,000 have to go through to get to the end of the 6 years? Now, this is only going to grow for 1 year in the green because it's got the difference between here and here. So 1 times 12. Now, what is this going to be? It grows for all 4 years. So that's going to be 4 times 2 to give me the 8. Now, what are we getting for? Aha, Kirsten, good question. Okay, can you see that the 2,000 only arrives on the scene in year 5? That's going to be my tip. So it only has to go through the blue journey. And in fact, it only has to go for 1 year. So see if that can help you, Kirsten, while I work out what the second deposit ends up being, because I need to do some calculator work here. Okay, so I am getting 8581.27 if I round off. Now I still have to figure out what the 2000 grows to. And then what I want to ask you is, for the fourth one, I want to ask how much is in the final pot after all the different deposits have had time to grow. So what was the interest rate here? It was a half yearly rate over 2, but it only gets to grow for 1 year. So we go 1 times 2. What am I going to get for that? 2000 times 1 plus over 2 to the power of 2. I get 2221.83. Now there will be a slight rounding difference if you did this all at once, or because we've chopped off some of the decimals. But what's my final amount going to be if I add up all these and it's sitting in the account? What is the lucky Sipo sitting with in his bank account? It should be 68. Now, there will be different, so some of you would get, there'll be slight differences. If you do it this way, you would get 820.61. If you are rounding, if you didn't round off as you went, there could be some slight differences compared to that. So I think I saw one student here, Clamelo. I suspect that is because of the rounding, like we've lost some of our decimal places here. But as long as we've showed our working clearly, then there shouldn't be a penalty, because the teacher can clearly see that we've rounded off at those steps. Okay, any questions? I know that was a tough one, but I know we did something like this in the last lesson, and I felt like I needed to do it nice and slowly. So give me an indication of how you're feeling. Thumbs up if you sort of are following this. Thumbs down if you're still feeling very confused. And if you are, that's completely fine. I just want to keep chipping away at understanding this. Okay. We're going to do more after the break, but I just think we need a bit of a break. Take a screenshot if you need to, if you want to preserve some of this working. And then we need a break because we've been going for a while now. All right. On your feet, everyone. Let's see those webcams on. Let's make sure that we just give ourselves a time just to unwind. Oh, and let's just stretch our arms a bit, and let's take some nice deep breaths. Okay, so we'll start in 3, 2, 1. Let's breathe in and breathe out. One more. Okay. Then let's do some rotating. So just a little gentle rotation to start with. And then as you feel yourself loosening up, you can start swinging things around. Okay. Then let's do some small circles with the arms going into big circles. And then change direction. So big circles going backwards into small circles. Okay, let's do some triceps. And stretch. And stretch the other arm. And then just shake it out. So shake out the arms, shake out the legs, shake out whatever else you want to shake out, and then hopefully you are feeling a bit relaxed. Let's do some heart rate stuff, and let's just do normal skipping stuff, and we'll do 20 in 3, 2, 1. Let's go. Halfway. Five more. And hopefully your body is appreciative of our efforts to give it some time off. Here are your 3 Maths 24 questions. See if you can solve any of these. If you can, pop your answers in the chat. Bonga Corsi, do you recommend doing the calculation separately or at once? I keep making simple errors when I do them separately. So Bonga Corsi, I would say that if you can get them right in that longer step, and you know, most of the marks for the teacher come from just seeing the working. So the final answer is only going to be worth 1 mark. So if your structure, let's say it's a 7-mark question, as long as you've written out and I can see that you've gone through the timeline and you know it's a green part and then a blue part, I mean, you don't have to use the colors, but you need to have the right numbers, then you're going to get 6 out of 7 anyway. At that point, it becomes a personal choice. Okay, and then just see which one you're getting right more often and kind of go with what works for you, because people have different things that they get wrong. So it's hard to know, give a general recommendation. Okay, well, the first one has fallen, chop chop, and that goes to Tati. 6 times 2 plus 6 times, oh, but hold on, we've used 2 twice, so that can't work. And Paul has said 6 minus 2, which is 4, times 6 times 1, so that's 24. And then Kitsaw has claimed the yellow, 8 minus 3 minus 1. Oh, wow, we're getting sneaky. And then that, so that's 2, that's 6, and then that's 4, which is 24. And Andile has said, oh, you guys are whipping out the brackets here, 7 minus 6 plus 1. So that would be, no, I don't know if I agree with that, because 7 minus 6 is 1 plus 1 is 2. Or 7 minus 6 is 1. Let's have a look. The blue one's tough. 8 minus 7. Let's have a look. 8 minus 7 would give me 1. 1 times, 1, I'm thinking 1 plus 2 is 3. 3 times 6 is 18. No, not quite. 7 minus 6 plus, there we go. 7 minus 6 is 1. 1 plus 2 is 3. So let's just check. 7 minus 6 is 1, plus 2 is 3, and then 3 times 8 gives us 24. Yep, there we go. The blue one felt harder than the yellow one there, but well done to everyone who attempted those. And it just keeps our brains nice and sharp. And it's something to just sort of break away from the lesson for a second or two. Okay, let us go to a different type of question. And we're only going to do 1 or 2 of these. And it's just a slight variation of what we've been doing so far. But take a moment to read the question, and I want to know from you, and I'd love to hear a voice or a comment about what is different about this question. What is different about this question compared to the previous one? Okay, and Kosi has said, and Manuel and Paul and Shamelo, 5,000 is drawn. Now, the problem is it's withdrawn somewhere on the timeline. And if it's withdrawn somewhere on the timeline, you get interest for the time it was in the bank. But then once that 5,000 leaves the bank, you do not get more interest on it. And so we need a clever mathematical way of dealing with this 5,000. But like all things, like these complicated questions, we do a timeline first. So all I want you to do is I want you to first do your timeline. And then once you've done your timeline, say done, and then I will show you the way that I think makes the most sense to deal with it. And it's one of these, like, just your timeline can be adapted, but you go first, see if you can do your timeline. So in Paul, we don't use the compound decay. Well, we use, I'll show you now, don't worry. It's not actually hard, but I want to wait until we get there before I start trying to explain. So just start with the basics. Get a feel for the question, and we just start with, what is the timeline? What is the life of this question? Well, I'm scanning for first 18. It feels like T5 is the end of the line for this one, because it says how much will be in the account after 5 years. So that's the journey, but there's obviously lots more stuff going on here. And I want you to try and put it on your timeline before I do. It's a good practice question. Just let me know in the chat when you feel like you have got the basics of your timeline down. Why does my timeline have a T1.5? Where does that come from? Because I see a T0, I see a T5, but suddenly there's a T1.5. Now where's that come from? Mukle has noticed that 18 months is just 1.5 years. And so that makes sense because I'm trying to keep my timeline in terms of years to start with. Fantastic. And Kirsten's also noticed. Okay, now I'm going to say that the 60,000 is not too exciting. So we know the 60,000 goes in, and I want to suggest that let's just pretend that there's no withdrawals at all. Can you tell me how much you end up with at the end if your 60,000 goes through the journey of getting through the red? and then getting through the green. How much do you have in the bank account after 5 years if we ignore the withdrawal? We're just going to ignore it. I'm using my teacher powers. So what are we going to end up with over here? And here, I suppose we're going to have 2 parts there. I've been making these square just to make them difference there. How long do we have? We have half, 3.5. But that needs to be times by 12. Okay, so how much money do we have in our bank account if we just ignore the 5,000 withdrawal? Give me a thumbs up if you can get to 79,286.89. Let me zoom in a little bit too. Okay, now here's the thing. Clearly, that's not the final answer, right? The final answer needs to deal with the fact that I took 5,000 out at some point. Ashton, we're going to start with a new topic on Monday. This is the last lesson on financial maths. Okay, so let's do this last bit. Now, where would the 5,000 fall on the timeline? Okay, it says to me 3 years. So at T3, this is when 5,000 is taken out. Am I going to put plus 5,000? No. What I put on my timeline is I put minus 5,000. Why do you think I say minus 5,000 instead of plus 5,000? Why do you think instead of putting a plus there, I'm going to put a minus? Okay, so it's to help my brain understand, look, 60,000 rocks up over here, it grows and it gets there. Here, this is taking money out. Okay, so you all understand why it's a minus. Now, if I said to you, the final answer is 79,286.89 minus 5,000, would that be wrong or would that be right? So if I say to you, I'm just going to take 5,000 away from this, and then I've got the final answer, would that be wrong or would that be right? What do you think? Ooh, it'd be wrong. I think some of you know quite a lot. Who would like to tell me why I can't just take 5,000 out and then I'm done? Case closed. Who would like to give some evidence supporting their claim? Kirsten, it is financial maths should be in the final curriculum, yes. Okay. I didn't take into account the interest. Yes, I pretended that the 5,000 was just taken out. But in reality, because I didn't take it out, it actually grew a little bit. So all you need to do is you go, okay, how much did the 5,000 get in interest? And because the 5,000 is sitting here, I want to suggest it only gets the green interest. So it goes 1 plus 0.05 over 12. What is going to be over here? What is going to be over here? So how long would the 5,000 have grown if I left it in? Remember, we're assuming we just left it in, and now we're trying to take it out at the end. And if we're going to take it out in the end, it actually would have grown had it stayed. So it actually only has, no, I think it only came in. It actually has only 2 more years it would have stayed in the account. So it left after 3 years, but if I kept it in, it would have stayed in for 2 more years to grow. So it's a sneaky thing, but can you see if you took it, I pretended to not take it out. I should have taken it out over here, but instead I left it in and it grew. So actually it grows for 2 more years. And so if it grew for 2 more years, I want to suggest that this is 2 times what? It's going to be 2 times. Now, if I look at the 12, it's 2 times 12. I want to know, what is this amount over here going to be? So remember, I left the 5,000 in too long. It grew too much. What does this 5,000 grow to if it's left in for 2 more years? See if you can work that out on your calculator. What does that grow to? It has to be bigger than 5,000. Okay, so I see this request to explain, so I'm going to explain again, Nompilo, don't worry. Okay, the way I'm dealing with the withdrawal is the following. I'm saying I first of all pretended the 5,000 never left. And so I let the 60,000 grow to this very big amount. But I should have taken the 5,000 out at the end of year 3. Okay, it says here 3 years after the initial investment. So I should have taken it, but by mistake, I left it in. How long did the 5,000 get interest on that it shouldn't have? So it shouldn't have got interest from year 3 to year 5 because it shouldn't have got interest there. That's the bit that I'm interested in knowing how much extra is in there by mistake. So I don't know if that helps you understand a little bit. Okay, now, it turns out that I can't just take out the 5,000. I need to take out the 5,000 and the extra interest that it earned because I left it in by mistake. So the final amount that is sitting in my bank account should be this amount minus this amount. And what do you get when you take out the 5,000 plus the interest that you worked out? What is my final amount sitting in my bank account? I need to do it as well. We should have 73,762.18. So if you have to deal with withdrawals, what is the difference to before? There's not a lot of difference, but there is some difference. The first thing that you need to think about is when you put a withdrawal on your timeline, you don't put a plus there. What you do is you put a minus. And the reason you put a minus is that you want your brain to know that this is not an extra amount that's going in, this is a withdrawal. But what you do is you don't just take out the amount that you withdraw, because the easiest way to do this is assume that it never happened. So I assume it never happened and I got an amount as if it never happened. And then you deal with the fact that you left it in too long. And to deal with the fact that you left it in too long, you have to take out the original 5,000, but you also have to take in the extra interest that was included by mistake. And the extra interest is going to be the period from when you should have taken it out to when the question ends. And you then need to subtract that amount from the original amount, and you get your final answer. Now, that is a tough one. And what I'm going to suggest is that you guys re-watch this last little bit again, but you'll see that the logic makes a lot of sense if you go over it again.